All right, this is a mini tensile testing machine from AHP Plastic Makina. I'm going to demonstrate briefly how it works. You see, includes the two types of grips here. This setup is especially designed for flexure testing. This is the sample piece for Flexural Modulus testing. The span length is about 66 millimeter, I think. And here. And in the back side, you have a mini wedge grip for tensile sample piece of ASTM samples here. You can open these grips by these two screws and use the wedge grips, mini wedge grips for the normal standard tensile testing. The setup is like this. You can use it vertically, attach it to screw it to the wall, and the controller is here. One cable coming to the testing unit. The other one is communication cable, that is converter, and the power cable. And two buttons for moving it upward and downward. And fully computer controlled. Here we have a setup for testing. The software is a standard tensile testing software. First of all, I'm going to show you how to calibrate it. For calibration, the calibration procedure is very easy. When it's in this mode like this, the load cell is here. With no force, you need to click on 0. And with a definite force, for example, this is 1.9 kg with a definite force that you will hang here. We will hang it here, for example, from these points. This is 1.9 kilogram, meaning 18.639 Newton. You will put the value here in terms of Newton. And after hanging this sample piece from here, you will click on scale, and the software will be calibrated with the load cell will be calibrated with a definite weight, and that's all. After clicking on scale, you need to click on quit here, and the software is already calibrated for the load. For the displacement calibration here, you have a displacement showing the distance of travel. You will calibrate using this factor. And for the speed calibration, you have the parameter here. That's all. It's very easy to calibrate. And then I'm going to use the machine for flexural measurement. The flexural measurement is according to ISO 178. It's easy here. You have a flexural stress, and flexural modulus is this will be calculated using this formula. The epsilon 1 is 0.0005, and the other one, epsilon 2, is 0.0025. And between these two displacement, we will measure the flexural modulus as this formula. For these two specific flexural strain, the software calculates the displacement related to this strain, and between two points, it will measure the flexural modulus using this formula. Epsilon 1 and epsilon 2 is the two values here, you see, relating to this value of epsilon, the strain, and the strain of the second point is here. The sigma F2, sigma F1 is the flexural stress related to that two displacement point using this formula. This one, flexural stress. Software is working based on this formula. It's easy. You can also use it for any 2-point of displacement. It can also calculate the flexural modulus between 2 points, 2 cursors that you're defining on the graph, flexural graph. When you're doing the flexural testing, you will click on bending. You will put the sample parameters here, the width and the thickness, and ls is the span length. And here, let's get ready for measurement. Speed need to be very low. I'm putting here 1 millimeter per minute. First of all, let bring it down so that it touches the sample. Yeah. First, I'm putting, for example, 100 millimeter per minute here, and then I'm bringing the head down using this key so that the sample piece touches the top fixture, touching the sample. For accurate measurement of the accurate defining the point of the touching of the top fixture with the sample piece, you can put it in lower speeds here, and then zero the force, and then bring it down using these buttons. You see it's coming down, and here when the force starts going up, means that the top fixture touches the sample. You see 1 Newton, 2 Newton, and just I'm making it 0, only, for example, 1 Newton, or any low value for the force. Yes, it means that the top fixture touches the sample. Yes, yeah. Now the top fixture touches the sample piece here. I just put the sample piece here, and it touches the sample piece, and now it's ready for measurement. Making the force 0, also the distance 0. Yes, I'm clicking on bending, selecting bending test, the speed to 1 millimeter per minute, and let's start testing. You see the speed is very, very low, as 1 millimeter per minute. It has there is very small gap between the top fixture and the sample. Yeah, now it touches and starts the measurement. Force is going up. Now the graph is very zoom. Here you can also define the top and bottom levels for the scales. Vertical scale is the force, and the horizontal is distance. 1 millimeter displacement is enough for the measurement of flexure. I'm just clicking on stop. Because the flexure is measured very low value for the displacement. It is, for example, the first displacement is about 0.1 millimeter, and the second measurement point is about 0.564, and it depends on the thickness and dimensions of the samples. This is the first cursor. I'm putting it here in low displacement value. And here the second cursor, I'm putting it to, for example, 65. Suppose that 2 displacement values related to the flexural strains here defined in the standard ISO 178. Suppose that the displacement related to these two values of the flexural strain are these values. I'm putting the curses here, and it calculates the flexural modulus. You see the flexural modulus here. Yes, it's the way of measurement of the flexural modulus using a mini tensile tester from AHP Plastic Makina. It's very easy to use, easy to work with it, and also very economical in terms of price. And using this mini machine, you have full functions of the tensile tester as well. And this is AHP Plastic Makina. Thank you.